Okay, so I want to talk a little more about the chain rule. I've put one video out to you about the chain rule, but I want to go ahead and elaborate a little bit. Let's suppose that we have a function. Let's suppose we have f of x equals sine x. Now, we know how to find the derivative of that function. It's just cosine x. Now, there's a difference between f of x equals sine x and this function, g of x equals sine 2x. So the derivative is going to be different, and it makes sense. Remember, the derivative is the slope of the tangent line at a point. So it makes sense that the slope would be different for sine 2x than it is for sine x. Well, it is different, and so when we're finding the derivative, we go this way. We take the derivative of sine just like usual, and we keep the 2x. But we have to remember to take the derivative of the inside, the derivative of the 2x, which is 2. Now, if we tried that over here for f of x, we would take the derivative of x and just get 1. So really, we don't need to think about the chain rule for f of x equals sine x. Now let's think about this one. Let's suppose that we have y equals, let's say 3x plus 7 to the 5th power. And we want to find dy dx, the derivative of y with respect to x. Well, so we've got to figure out, okay, which order do we differentiate? And one of the ways I think about it is this. I say, well, we want to start with, think about if you were evaluating this function. If you were evaluating this function, you would start with plugging into the inside. So you would take the 3x plus 7. And then you would raise that to the 5th power. So we're kind of going backwards. We're going from the outside in. So I'm going to take this 5th power first. And I get 5. I'm just applying the power rule. Okay, so there's the power rule. And then I remember, okay, I got to take the derivative of the inside. The derivative is 3x plus 7, which is 3. So now, putting everything together, I can multiply these two and get 15 3x plus 7 to the 4th. And there's my derivative. So everything we've learned about, the power rule, the product rule, the quotient rule, all of that, we don't want to forget that when we're dealing with the chain rule. So for example, let's suppose that we've got this one. Let's suppose that we've got y equals, let's say 3x plus 1 squared cosine 2x. Now, of course, this is a product. So when we talk about dy dx, we're going to take the derivative of the second. Okay, let's think about that. That's going to be negative sine 2x times 2. Don't forget the chain rule. Times 3x plus 1 squared. Now plus, now I got to take the derivative of this first one. Applying the chain rule. Okay. Times the second. Ran out of room. Okay. So notice, here's the derivative of the second times the first, plus the derivative of the first times the second. Now what we need to do is simplify. So let's see if I can simplify this. I don't think there's going to be a whole lot of simplifying to do. On this first one, I can write this as negative 2 3x plus 1 squared sine 2x. And then over here, for the second one, I can put plus 6 3x plus 1 cosine 2x. There we have it. Okay, so there you can see another example of the chain rule. Now, let's look at this one. Let's suppose that we've got the square root. Actually, let's do this. Let's do x squared times the square root of 3x plus 5. Okay. Now, I'm going to go ahead and write that as x squared 3x plus 5 to the 1/2. Just because we want to be able to use the power rule, and in order to use the power rule, we need to see what the power is. So the power of this radical is 1/2. Now here we go. Here's the derivative. dy dx is equal to, okay, I've got the first times the derivative of the second. Well, here's the derivative of the second. 1/2 3x plus 5 to the 1/2 minus 1, which is negative 1/2, whoops, times 3. Okay, times, well, that's it, right? So here's the first times the derivative of the second, plus the derivative of the second times the first. Now, what I want to try to do is clean this up a little bit. In other words, I want to simplify it. And there's some obvious simplifications that I can do right away. For example, I can take this 3 and this 1/2 and just say, well, that's x squared times 3/2, and here's 3x plus 5 to the negative 1/2, plus 2x, 3x plus 5 to the 1/2. So really all I did there was multiply. Now here's a trick I want to show you about simplifying. Notice I've got this negative exponent, negative 1/2, and I've got the positive 1/2 over here. What if I do this? What if I multiply the top and the bottom by 3x plus 5 to the 1/2? Well, notice, let's just think about this a minute. Oh. Okay, let's just think about it. Consider this. Think about x to the 1/2 times x to the 1/2. Well, I know that that's going to be x to the 1/2 plus 1/2, which is just x to the 2/2, which is just x. So if I multiply x to the 1/2 times itself, I just get x. Now, what if I multiply x to the 1/2, or negative 1/2, times x to the 1/2? Well, I get x to the negative 1/2 plus 1/2, which is x to the 0, which is 1. So the radical goes away entirely. With that in mind, what if I multiply this and this by 3x plus 5 to the 1/2? Now I can do that as long as I do it to the bottom as well. In other words, here's what I've got. I've got dy dx. And I've got up top here, I've got 3x squared over 2. And then here's what I have. I have 3x plus 5 to the negative 1/2 plus 2x, 3x plus 5 to the 1/2. And I've got that all over 1. Now here's what I want to do. I want to multiply the top and the bottom by 3x plus 5 to the 1/2. Now that doesn't hurt anything because I'm just multiplying by 1. See, 3x plus 5 to the 1/2 over 3x plus 5 to the 1/2, that's just 1. Now, what I want to do is I want to distribute through here. So here's what I have now. I have 3 halves x squared times 3x plus 5 to the negative 1/2 times 3x plus 5 to the 1/2 plus 2x, 3x plus 5 to the 1/2 times 3x plus 5 to the 1/2. And then on the bottom, of course, I've got 3x plus 5 to the 1/2. So here's what I did. I multiplied the top by this and the bottom. Now let's see what we've got. This just reduces to 1. So I've got 3/2 x squared. This whole first term here just reduced to that. Over here, I've got 2x times 3x plus 5. Because this and this, these two multiplied together just gives me 3x plus 5. And then I've got, of course, the radical on the bottom. Now I still don't like the fact that there's a fraction up here, this 3/2. So what I want to do is I want to multiply the top and the bottom by 2. And then I get this. I get 3x squared plus 4x Here's what I have so far. See, all I did was I multiplied everything by 2. I multiplied this by 2, this by 2, and this by 2. Nothing wrong with that. Now I clear my parentheses and I get 3x squared plus 12x squared plus 20x all over this thing on the bottom. Okay, let's see what I got now. I've got 15x squared up top. And on the bottom, I've got this. There. And that's a nice simplified derivative. And of course, you could factor an x out of the top, but I don't see any point in that, really. Okay. Now let's look at another one. Let's suppose we've got y equals, let's say 3x plus 7 over 5x plus 2 to the, 9th power. Something like that. And we want to differentiate that. Okay. So we take the derivative of the outside first. Okay, so here I applied the power rule. Power. Okay. Now I multiply this by the derivative of the inside. Okay, so I have the derivative of the top, which is 3 times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. Now here's the thing. It's a very rare situation where you'll actually multiply out the bottom. So don't try to multiply out the bottom. Just leave it the way it is. Now let's see what we've got here. If I simplify this, nothing to simplify here yet. Let's see what we've got in here. I've got 15x plus 6 minus 15x minus 35. So I just multiplied out everything. Now if I add like terms, notice these 15s cancel. So now I've got 9 3x plus 7 over 5x plus 2. And then here's what I've got in here. I've got, looks like this is going to be negative 29. Okay, now one of the things we can do a step further, we can simplify. Here's what we've got. We've got 9 times negative 29. I'll just put this together with the 9. Times 3x plus 7 to the 8th. And now look at this. Here's 5x plus 2 to the 8th, 5x plus 2 to the 2nd. That makes 5x plus 2 to the 8th, 9th, 10th. And this will give us negative 261. 3x plus 7 to the 8th over 5x plus 2 to the 10th. Okay, so practicing these take a lot of practice. And what I've tried to show you is just some things that you'll run into and how you can get the simplified answer so that you'll get it right in Math Excel, and also so that you'll be able to match your answers in the book to the answers in the back of the book. Working through these problems is very important. So be sure you work through those. If you don't understand something, be sure you ask me about it.